Hey guys, Ed here with another installment of the DIY CNC turret lathe. This is a dedicated machine to produce these magnetic plugs for the holes in our fixture plates. This week we'll be machining and 3D printing the components for the Ratchet Pawl assembly, machining the Ratchet Wheel, cutting out the tailstock plate on the Boss laser, and machining the Z slider cap and Z-Servo bracket. Welcome to another Wednesday widget. In the last episode, you saw us hard mill this high-speed steel form tool, which will be used to cut the profile of these plugs. Card to that video, as well as the current F3D file here. First up, we have the Ratchet Pawl block. This is the base of the Ratchet Pawl assembly, which acts against the ratchet wheel to rotate the turret. Facing with the Superfly at 2500 RPM and 8 thou per tooth, which ends up being 20 inches per minute. Drill 2 number 7 holes for quarter 20 taps. Then coming in with a long 1/4 inch end mill to clean up the sides of the part so we can use these to indicate the next op. And lastly for this op, breaking the edges with my favorite, the 4-flute 3/8 chamfer mill from Lakeshore Carbide. Then we'll rotate the part 90 degrees for the main op. Here we're indicating off the top of the parallel to ensure that part thickness is accurate. .3D adaptive with the 1/4 inch 3-flute variable flute end mill from Lakeshore Carbide, maxing out our RPM on this machine at 7500, feeding at 3.5 thou per tooth, which ends up being 80 inches a minute. And the same tool will finish up the profiles with a 2D contour. Spotting and drilling the pinholes for the Ratchet Pawls. And break the edges with that same chamfer mill. We run this chamfer mill at max RPM, again 7500 in this case, and 2 thou feet per tooth. Over to the Arbor press to press in the pivot pins for the Ratchet Pawls. And finally to this 770 with a vise on it so we can drill the third op, which is a hole for a pin to guide the return spring. Now onto the Ratchet Pawl reset bar. This part transfers the force of one spring to all 3 pawls to reset them during the course of the ratcheting action. For this slot, we're using a 3/32 2-flute end mill, and the trick I found for slotting like this is to use the ramp feature in 2D contour. We have the ramping angle set at 2 degrees, although that's really governed by your maximum ramp step down, which I like to keep around 10% of tool diameter. Match your ramp feed rate to your desired cutting feed rate, which in this case is around 40 inches a minute. Seems to work really well, and so far I've had no breakages or issues at all when using this recipe. Pre-drilling here just to keep these radii tight on the profile. Following that up with a 3D adaptive to rough away most of the stock. .2D contour, same tool, 3 flute, 1/4 inch. And then back to the 3/32 2 flute to clean up those tight radius corner transitions in one pass with another 2D contour. Only rough indicating in X and Y at this point, just so we can get that hat out of the way. And once that's gone, we can re-indicate and go from there. Third op on this part, over on that 770 again, is a clearance hole for the spring guide pin. For the Ratchet Pawls themselves, over to the Markforged Mark II 3D printer. The printed versions that I was using in testing held up great, so they were deemed good enough for permanent use on the machine. Card here for our in-depth video on this printer. Now on to the Ratchet Wheel, which I decided to make from Delrin to keep friction in the assembly as low as possible. Op 1 facing with a Superfly. This was my first time using our new Pitbull mod vise, And I have to say the extra holding power is great to have in any case, but especially with a slippery material like Delrin, where it might want to pull out of smooth vice jaws. This didn't budge. .2D adaptive here with our standard 1/4 inch 3-flute Lakeshore carbide end mill. Then coming in with an 1/8 inch to clean up the tight radii and a final contour with that, and finishing this op up with an edge break. Testing out laser cut soft jaws on the other side there with our mod vise soft jaw setup. Seemed to work really well, especially for a relatively low precision op like this where we're just taking off the hat and chamfering. And here we're cross drilling the ratchet wheel and shaft all in one go for the spring pin that holds them together. Due to popular demand, we decided to make the tailstock plate out of 1/2 inch clear acrylic so we could see that ratchet mechanism in all of its glory. So here you go. Now we'll make the Z slider cap. This transfers the Z ball nuts motion through the turret to the tailstock plate. Also went with Delrin for this component for the same reason. We want low friction. I went with this 1/4 inch tool here over the shear hog we would usually use to take off the hat, just to make sure we avoid pulling this slippery Delrin part out of these smooth jaws. With that hat out of the way, we can now come in and re-indicate X and Y precisely for this chamfer, and break the edges. Lastly, the Z-Servo bracket. We've been using Fusion's both ways adaptive a lot more on this Beta 1100MX machine. The reduction in cycle time is much more appreciable with the quicker acceleration and feed rates given to us by the servos. To learn more about both ways adaptive in Fusion 360, card here. From here we'll finish up this off with a 2D contour, 1/4 inch 3 flute. And edge brake chamfers. You know the drill by this point, so I don't think we have to show it. Re-indicate X and Y after the hat's out of the way, and then finish it up by facing it, drilling some holes, and breaking those edges. If your part geometry is right, you can just use the Modvice soft jaw bases to hold parts vertically for these sorts of drilling ops. Works great in my experience. On to some assembly. First up, mounting the master rail for the X-axis, squaring that against the bed. Then the second X-rail is mounted parallel to this. Next up are the tailstock risers. And we just used a 246 block to square the master Z rail to the master X rail. And again mount the other Z rail parallel to the master Z rail. Mounting the X cross slide plate we made a couple episodes back. In the next video, we'll have enough parts finished where we can start playing with the Arduino code and get this turret moving, and take a look at starting on that spindle project. Hope you enjoyed, and thanks for watching.